On March 21, 2025, President Trump announced America's next fighter jet, the F-47, built by Boeing, and it's designed to fly alongside autonomous drones that take orders from the pilot, such as the Collaborative Combat Aircraft series of drones currently in flight test. This isn't another incremental upgrade. So, what exactly makes the F-47 different, and why did the Air Force nearly cancel the entire program? The F-47 is the newly revealed designation for what the Air Force has been calling NGAD, Next Generation Air Dominance. It's replacing the F-22 Raptor as America's premier air superiority fighter, 6th generation, first of its kind in operational service. The F-47 isn't really one aircraft, it's a family of systems, one crewed fighter plus multiple uncrewed loyal wingmen, all working together through advanced networking architecture. Air Force Chief of Staff General David Alvin called it the most advanced, lethal, and adaptable fighter ever developed. The name references the P-47 Thunderbolt from World War II. The Air Force plans to buy around 200 to 250 aircraft to replace F-22s currently in service. That sounds small until you factor in that each F-47 controls multiple autonomous drones, over 1,000 aircraft when you count the entire family. The program then faced a critical hurdle. NGAD began as a DARPA-driven concept in the mid-2010s called the Air Dominance Initiative, ensuring US air superiority beyond 2030 against peer adversaries like China's J-20 and Russia's Su-57. By September 2020, the Air Force revealed they'd already built and flown a full-scale demonstrator in secret. In May 2024, Air Force Secretary Frank Kendall paused the entire program. The reason was in part cost, with early estimates around $300 million per aircraft. Additionally, Secretary Kendall wanted to ensure his replacement owned the decision to commit resources. 8 months later, Major General Joseph Kunkel stated there was no more viable option than NGAD to achieve air superiority in this highly contested environment. The program was back, with detailed cost analysis to follow. Boeing won the contract over Lockheed Martin, more than $20 billion for development and initial production, and Boeing committed to something that made the difference. The F-47 is the first fighter developed under the Digital Century series philosophy, fundamentally changing how fighters get built. Instead of 30-year programs, this means rapid digital design and modular production. Design it digitally, build it in small batches, repeat every 5 to 8 years. The F-22 took over 20 years from concept to operational capability. The F-35 is still being modified decades after first flight. China rolls out new fighters every few years. America can't take 20 years to respond. Former Air Force acquisition executive Will Roper developed this concept. The F-47 is entirely digitally engineered. All design, simulation, and certification performed in virtual environments before physical production. This cuts development time from 20 years to under 8 years. Dr. Roper claimed it could reduce modernization costs by 79% and sustainment costs by 50%. It's open architecture, avionics, mission systems, and sensors designed for plug-and-play upgrades. Modular construction allows for different versions: long-range interceptor, strike variant, and potential carrier variant for Navy NGAD. The F-47 is manufactured using advanced additive manufacturing and robotic assembly. Most design details remain classified, but we have clues. Boeing released graphics showing only the nose section. March 2025 concept art suggested the F-47 may include canard foreplanes. Those small forward wings help with maneuverability, but traditionally compromise stealth. Defense analysts think it's because perfect stealth is no longer possible. Low-frequency radars can already detect stealth aircraft at longer distances. So, the designers concluded that since you can't be invisible, you need to be fast and agile enough that it doesn't matter. Concept art shows blended wing, lifting body geometry with a diamond-shaped planform. The design is optimized for both stealth and high lift, with straight leading and trailing edges, prominent chines similar to the F-22, and engines fully buried in the fuselage. The Air Force refers to the stealth capabilities as Stealth 2.0, compared to the F-22's Stealth 1.0. The airframe is optimized for Pacific theater operations, with larger internal volume for fuel, designed for combat radius exceeding 2,000 nautical miles. The flight systems feature artificial intelligence-assisted controls, where the pilot acts as the mission commander rather than the stick and rudder controller. The F-47 uses adaptive cycle engine technology from either GE's XA-102 or Pratt & Whitney's XA-103. These aren't conventional turbofans, they adjust airflow dynamically between high speed and cruise efficiency modes. The engine has an adaptive fan with a variable bypass ratio. Need to cruise efficiently? Increase the bypass ratio. Need maximum power for combat? Adjust for peak thrust. The engine adapts in real time. Performance numbers are significant, up to 25 to 30% greater range than current 5th-generation engines, 20% more thrust, and improved thermal management for directed energy weapons. The F-47 has range 50 to 80% greater than the F-22, large internal bays for long-range missiles and hypersonic weapons, and can reach speeds beyond Mach 1.5, possibly approaching Mach 2 in supercruise. Maneuverability is comparable or superior to the F-22, potentially with thrust vectoring. The F-47 features integrated multispectral stealth, not just radar cross-section reduction, but infrared and visual signature reduction, conformal weapons bays minimize drag, and radar reflection. Everything is internal. The electronic warfare suite is AI-driven, with adaptive jamming that learns threat signatures in real time. The aircraft can also launch small decoy drones that mimic its radar signature, making enemy missiles track false targets. Combined with stealth shaping, advanced materials, and electronic warfare capabilities, the F-47 is designed to operate in airspace where older fighters couldn't survive. The central concept is straightforward. The F-47 is the quarterback of a networked formation of autonomous or semi-autonomous drones, operating alongside collaborative combat aircraft, CCAs, smaller, cheaper wingmen built by Boeing, Anduril, and General Atomics. Air Force Secretary Frank Kendall stated the service plans to field 200 NGAD fighters and 1,000 CCAs, 5 drones for every manned fighter. First CCA flight tests began in August 2025. These CCAs cost around $20 to $50 million each, compared to potentially $250 to $300 million for an F-47. You can accept the loss of an affordable drone. You can't accept the loss of a $300 million fighter with a trained pilot. The CCAs act as scouts, missile trucks, decoys, or sensor relays, expendable assets coordinated by the F-47's onboard AI. Secretary Kendall explained, "One way to think of CCAs is as remotely controlled versions of the targeting pods, electronic warfare pods, or weapons now carried under the wings of our crewed aircraft. Instead of hanging pods on wings, you distribute those capabilities across autonomous aircraft. The concept includes data fusion links with the E-7 Wedgetail AWACS replacement and satellite networks to form a distributed sensor grid. The F-47 sees what all its drones see, plus what satellites and other aircraft see. The pilot makes tactical decisions while the AI executes them." DARPA's Alpha Dogfight program demonstrated that AI can outperform human pilots in simulations, but the F-47 doesn't pit human against AI, they work together. The F-47 features a cognitive AI co-pilot that handles threat prioritization, target tracking, and system management, while the pilot focuses on tactics and strategy. Air Force Secretary Kendall personally flew in the X-62A Vista under AI control to validate these capabilities. The cockpit features augmented reality displays with a fully digital canopy HUD and minimal physical controls. The F-47 is designed for optionally manned capability and could fly autonomously in future upgrades. Current technology requires a pilot, but the architecture allows for fully autonomous operation if technology advances. The primary application elevates human pilots to mission commanders, with AIs as loyal wingmen operating under tactical control. The F-47 is built around the Joint All-Domain Command and Control Framework, a network that connects air, space, and cyber domains. The jet acts as a node with real-time data exchanges with satellites, ships, and ground units. Sensors from the F-47, its CCAs, satellites, AWACS, and ground radar all feed into one operational picture. The AI processes this information, highlights threats, identifies targets, and suggests tactics. The F-47 uses secure optical and quantum-resistant data links to protect communications. And critically, the jet can operate independently if cut off from the network, defaulting to operating independently with its CCAs until connectivity restores. This networking capability fundamentally changes what air superiority means. It's not about having the best dogfighter, it's about having the best information and using it faster than your opponent. The estimated program cost is over $20 billion for development and initial production, per unit cost projected at $250 to $300 million, depending on configuration, twice the cost of an F-35. Initial production runs planned for around 200 to 250 aircraft. The NGAD family, with CCAs, may exceed $100 billion total program value. How does the Air Force justify that cost? The fleet multiplier effect. Each F-47 controls multiple uncrewed assets. You're not buying one fighter, you're buying a formation. General Alvin stated the F-47 would be less expensive than the F-22 and produced in greater numbers. Digital design per Digital Century Series principles reduces development costs and compresses timelines. The Department of Defense's 2025 budget allocates $19.6 billion over 5 years for NGAD-related development, plus the $20 billion contract value. That sounds substantial until you compare it to the F-35 program, which has cost over $400 billion. The economics work better when you factor in 1,000 CCAs at $20 to $50 million each. The F-47 replaces the F-22 as the high-end air dominance platform, complementing the F-35 multi-role fighter. It's designed for contested airspace over the Indo-Pacific, where range, stealth, and networking are critical. Every capability reflects specific theater requirements, vast distances, and sophisticated threats. The F-47 will integrate with Navy NGAD, the FAXX program, for joint operations. Beyond combat capability, the F-47 serves as a deterrent technology demonstrator, signaling continued U.S. aerospace capability. The F-47's development is explicitly tied to countering China's J-20 and emerging sixth-generation prototypes in the Indo-Pacific, where vast distances demand superior range and networking. Trump's March 2025 announcement emphasized it as key to maintaining America's air supremacy over China. In 2020, the full-scale demonstrator flight was revealed. In 2024, the source selection competition narrowed to Lockheed Martin and Boeing. In 2025, the Air Force confirmed the F-47 designation and flight-ready prototype. Manufacturing the first F-47 began in September 2025. Low-rate initial production is planned for 2026 to 2028. First flight expected in 2028. Target date for initial operational capability is 2030, with the first combat-ready squadron operational by the end of the decade. The F-47 aims to go from first flight to operational capability in under 5 years. The F-35 took nearly 2 decades. Cost containment is challenge number 1. The F-35 became notorious for cost overruns and delays. The F-47 can't repeat that. Boeing has to deliver on budget, or Congress will reconsider the program. AI ethics and autonomy present another challenge. Command authority in human-machine teaming, who makes the final decision? The Air Force maintains that human control remains essential, but boundaries become less clear in combat. Cybersecurity is a genuine vulnerability. Networked systems create attack surfaces. The CCAs use secure line-of-sight communications, but nothing is completely secure. Industrial base strain is also a concern, producing adaptive engines and composite fuselages at scale while maintaining quality. Boeing's contract includes a $1.8 billion St. Louis facility for digital manufacturing, with upskilling for 5,000 plus workers in composites and AI. This mitigates supply chain risks identified in the 2024 review. Integration with existing fleets brings maintenance training, software standards, and logistics challenges. The F-47 uses entirely new systems, requiring new skills and adapted supply chains. The F-47 forces China and Russia to accelerate their own sixth-generation efforts. China's working on developmental sixth-generation programs. Russia has the Su-75, fifth generation, and PAC-DP programs. This is the new air superiority competition. Allies including the UK, Japan, and Italy are pursuing the Global Combat Air Program and FCAS in parallel, creating multiple sixth-generation ecosystems. The F-47 may follow export policy similar to the F-22, Air Force only initially, with potential export derivative later in the 2030s. The program could redefine air power economics, fewer but vastly more capable fighters leading mixed formations of drones, a fundamental shift. You don't need 500 fighters if 200 can each control 5 drones. President Trump suggested that reduced capability versions might be sold to US allies in the 2030s. The F-47 fighter is the first fighter built around AI collaboration and modular evolution rather than static design, making the transition from platform-centric warfare to network-centric autonomy. The F-47 prioritizes software and networks alongside its advanced airframe. Digital design plus AI may reduce upgrade cycles from 20 years to 5. New versions will emerge regularly, incorporating the latest technology. The F-47 is a prototype for how future commercial aerospace programs might adopt digital twin methodologies. Boeing's commercial division is observing closely. The AI integration matters beyond aviation. How do you balance human judgment with machine speed? The frameworks being developed for the F-47 will influence autonomous systems across all domains. The F-47 NGAD isn't just another fighter, it's the model for how future aircraft will be conceived, built, and operated. Its success or failure will define the pace of 21st century air power for decades. Boeing won this round, committing everything to digital design and a family of systems. The F-22 forced America's adversaries to build their own stealth fighters. The F-47 is forcing them to build entire ecosystems of networked AI-enabled systems, exponentially more difficult. Production of the F-47 is underway, defining future air combat. Manufacturing began in September 2025. First flight is targeted for 2028. In 3 years, we'll know if this approach works. If it does, the F-47 will be remembered as the aircraft that fundamentally changed air warfare. The F-47 isn't the end of manned fighters, but it might be the beginning of a transition. As AI improves and CCAs become more capable, future variants could operate with or without pilots. This architecture allows for that evolution. The F-47 heralds a new era in air dominance. Subscribe for more aerospace insights. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?